Neutron star mergers, cosmic collisions, and gravitational waves. Welcome to Wonderful Universe. If you're fascinated by the mysteries of space, you've landed at the perfect place. In today's episode, we're diving into one of the most powerful and awe-inspiring phenomena in the universe, neutron star mergers. Neutron stars are the ultra-dense remnants of massive stars that have undergone a supernova explosion. These stars, even though they're only about 12 miles in diameter, pack a mass that's often 1.4 times that of our Sun. To put that into perspective, a single teaspoon of neutron star material would weigh about 4 billion tons. It's hard to imagine something so small yet so dense, but that's the reality of these incredible objects. Now, imagine two neutron stars locked in a cosmic dance, spiraling toward each other for millions of years. As they inch closer, their gravitational pull intensifies, distorting space around them. Eventually, these two neutron stars collide in a dramatic explosion, sending shockwaves through the universe. These collisions produce gravitational waves, ripples in spacetime first predicted by Einstein in his theory of general relativity. For decades, gravitational waves were purely theoretical, but in 2015, scientists made the first detection using the LIGO observatory. Then, in 2017, LIGO and Virgo observatories made another groundbreaking observation, gravitational waves from a neutron star merger, known as GW170817. But the story doesn't end there. When these neutron stars merge, they release immense amounts of energy, including visible light, gamma rays, and radio waves, all observed from Earth. What's even more fascinating is that these collisions create heavy elements like gold, platinum, and uranium. Yes, that ring or necklace you might be wearing could contain elements forged in the heart of a neutron star collision, billions of years ago. This process is called our process nucleosynthesis, and it's responsible for producing some of the heaviest elements in the universe. The detection of GW170817 marked the birth of multi-messenger astronomy, where we observed both gravitational waves and electromagnetic radiation from the same cosmic event. This allows scientists to learn so much more about the universe, how matter behaves in extreme conditions, and how heavy elements are created and distributed throughout space. Neutron star mergers give us a glimpse into some of the most extreme and violent events in the cosmos. Not only do they confirm Einstein's predictions about gravitational waves, but they also show us how the elements that make up our world are created in the universe. It's a reminder that everything, our planet, our bodies, the materials we use, has its origins in cosmic processes billions of years old. Want to learn more about incredible space phenomena like neutron stars, black holes, and exoplanets? Be sure to hit that subscribe button and turn on notifications so you don't miss an episode of Wonderful Universe. We're constantly exploring the most fascinating discoveries that space has to offer. Thank you so much for watching and supporting the channel. We appreciate every like and every share. Join us next time as we continue our journey through the wonders of the universe. Until then, stay curious and keep looking up.